Hello everyone. In this video, we are going to see the next question of the power electronics. The question is, the steady state capacitor current of a conventional DC to DC buck converter working in continuous conduction mode is shown in one cycle. If the input voltage is 30 volt, the value of the inductor used in millihenry is dash, round off to 1 decimal place. This is the graph shown for the capacitor current. The capacitor current is shown here. The capacitor current, it is varying from minus 0.1 to 0.1. The time is given in microsecond. So we need to find out the value of the inductor in millihenry. That value should be round off to 1 decimal place. This is the solution of the given problem. We are given the capacitor current waveform. For a buck converter, we can take del IL equal to del IC. So since the capacitor current, it is varying from minus 0.1 to plus 0.1, the del IC, which is nothing but del IL, will be 0.2 ampere, because the current is varying from minus 0.1 to 0.1. So 0.1 minus of minus 0.1 will be 0.2. So that is given here. And the frequency can be taken as 1 divided by the time period. The time period of the waveform, it can be taken as 50. This is for one cycle, it is given. That is from 0 to 50 is 50 microsecond. The current, it is varying from minus 0.1 towards 0.1. Again, it reaches to minus 0.1 though. So the time period is 50 microsecond. So capital T is 50 microsecond. So that is taken here. F is equal to, frequency is 1 by time period, which is 1 divided by 50 into 10 power minus 6, which is nothing but 20 kilohertz. And the duty ratio is T on by T, which is equal to 30 by 50. So 30 is this one. During the on period of the switch, the capacitor current as well as the inductor current, it rises from the minimum value to a maximum value. So the time turn on time is nothing but 30 microsecond. So that is what here it is taken. The duty cycle is T on by T, which is 30 by 50, which is equal to 0.6. And we know that the ripple current expression del IL for buck converter will be alpha into 1 minus alpha into Vs by Fl. Alpha is 0.6, F is 20 kilohertz, and Vs, it is given that Vs, it is given that 30 volts. The input voltage is given as 30 volt. So we can find del IL equal to, substituting for alpha, Vs, F, and del IL, we can find L value as equal to alpha into 1 minus alpha Vs by del IL into F. Substituting alpha, Vs, del IL and F, we will get the value of the inductor as 1.8 millihenry. So this is the required value of the inductance, which is required to have the del IL equal to 0.2 ampere. Thank you.